Welcome back to the Deep Dive. We are looking at the week of January 18th to January 25th, 2026, and we're focusing exclusively on the Amazon Bedrock and AWS ecosystem.
It's been a heavy week.
It has. And, usually when we talk about AI, we're kind of stuck in this loop of, look how smart the chatbot is. You ask a question, it writes a poem, maybe summarizes a PDF.
Right.
But looking at the stack of updates from AWS this week, I get the sense that the whole chatbot era is, well, it's officially in the rearview mirror.
I think that's fair. If the last couple of years were about chat, this week really signals that 2026 is about industrialized agents.
Industrialized is a heavy word.
It is, but I think it fits. We aren't just looking at models that can talk anymore. We're looking at agents that have, long-term memory. We're looking at infrastructure that is physically isolated in Germany for sovereignty.
And systems that can just navigate the messy, broken web like a human would.
Exactly. And we have a case study from Amazon's own internal team later on that. It's just incredible. Supervisor agent managing worker agents. It sounds like corporate middle management, but for AI.
It does. I'm really looking forward to that one. But let's start at the foundation. So on January 20th, we got an update about Amazon Bedrock knowledge bases.
General availability for multimodal retrieval.
Right. Now, we've had multimodal models for a while. I can show a picture to a model, and it tells me what it is. How is this different?
So the key here is the retrieval part.
Yeah.
Before this, if you were, say, a media company with a massive archive of video and audio, searching it was a nightmare.
Yeah.
You'd have to transcribe the audio to text, maybe run a separate computer vision model to tag images, and then search those tags. It was a really brittle pipeline.
You're basically gluing 3 different technologies together and hoping they worked.
Exactly. What AWS launched, and it uses their Amazon Nova multimodal embeddings model, is the ability to create a unified vector space.
Okay, stop there. Unified vector space.
That sounds great on a slide deck, but what does it actually mean for a developer?
Think of it like a universal translator, but for math. The model takes a text query, an image, a video clip, an audio file, and it converts them all into the same type of mathematical representation.
A vector.
And because they live in the same space,
You can compare them directly.
so I don't need keywords.
No keywords. You can upload a photo of, say, a specific red dress, and the system can scan 10,000 hours of video to find the exact millisecond where that dress appears.
Or I could type, show me the scene where the car engine makes a grinding noise, and it searches the audio directly.
It searches the audio waveform directly, and the source material says it handles the segmentation automatically.
Oh, which is huge.
That's the industrialized part I mentioned. Usually a developer has to chop the video up into clips manually. This thing preserves the temporal context. It knows the grinding noise happened after the car started, but before the crash. It just handles the chunking for you.
That removes so much of the grunt work. But searching for data is one thing. Taking action is another. And that brings us to January 21st, when AWS put out a guide on using Strands agents with Meta's Llama 4.
This was a fascinating read. It really challenges this idea that you need one giant God model to do everything.
Right. The trend lately has just been bigger is better.
But in production, bigger is often slower and way more expensive. This guide focused on multi-agent orchestration, so they laid out a scenario, processing video streams for a smart city or industrial safety.
Okay.
And instead of one brain, they use 6 specialized agents.
Like a digital assembly line.
Precisely. You have a coordinator agent that just manages traffic. You have a frame extraction agent, a visual analysis agent. You get the idea. Each one is built on Llama 4, but they're tuned for a very specific sliver of the task.
So if the visual analysis agent fails, the whole system doesn't just crash.
Correct. And it lets you scale. If you get a sudden spike in video feeds, you just spin up more visual analysis agents. You don't need more coordinators. It's a microservices approach to AI.
It makes sense technically, but it sounds like a headache to manage. I mean,
Yeah.
If I have 6 agents, don't I have 6 times the complexity?
You do, unless those agents are smart enough to learn from their mistakes. And that brings us to the biggest product update of the week.
AgentCore episodic memory.
Yes. Launched on January 21st.
Okay, we need to be clear about this. This is different from what we usually call memory, right? Because
Yeah.
if I use a chatbot today, it remembers what I said 5 minutes ago. That's memory.
That's context. It's short term.
Correct.
Once you close that window, poof, it's gone. Or you might have semantic memory, which is just a database of facts, like knowing the company holiday policy.
Right.
Episodic memory is different. It is the memory of experience.
Experience.
It records how the agent solved a problem. It documents the goal, the reasoning steps it took, the tools it called, and most importantly, the outcome. Did it succeed or did it fail?
So it's keeping a diary of its own job performance.
In a way, yeah. The system uses something called a reflection module. And this is the critical piece. Let's say you have an agent designed to book travel. Yesterday, it tried to book a flight for a user, but it failed because it forgot to ask for a visa number.
Okay, happens.
The reflection module analyzes that failure. It essentially writes a note to itself. In the future, when booking international travel, always check for visa requirements first. The next time it runs, even for a totally different user, it accesses that memory.
So I don't have to go in and reprogram the prompt to say, check for visas.
You don't touch a line of code. The agent reprogrammed its own behavior based on past experience.
That sounds incredible, but I have to play devil's advocate here. If an agent is learning from every single interaction, couldn't it learn the wrong lesson? What if it hallucinates a rule that doesn't actually exist?
That is a very real risk. And that's why the architecture includes namespaces. The update mentions a hierarchy, something like travel bookings user ABC. So you can scope these memories. Lessons learned in one context don't just blindly bleed into another where they might not apply.
So it's not just a free-for-all memory dump.
No, it's structured. But the results, they're hard to argue with. They released a benchmark on retail tasks. Without this memory, the agents had a success rate of about 65.8%.
Which is, okay, I guess. But you wouldn't want to run a business on it.
Exactly. With a cross-episode reflection turned on, that jumped to 77.2%. That is a massive leap in reliability just by letting the AI think about what it did yesterday.
Reliability is key, but so is capability. Sometimes the AI fails just because the web is a mess. On January 22nd, AgentCore browser added support for custom Chrome extensions.
This is one of those updates that sounds minor. Oh, cool, browser extensions. But for enterprise, it unlocks everything.
My first thought was, great, now the AI can block ads.
And that is actually a valid use case. If you are building an agent to scrape pricing data from a competitor site, and that site is loaded with pop-ups and video ads, your agent is going to get stuck. Installing a .crx extension to block those distractions makes the agent way faster.
But I'm guessing AWS isn't targeting this feature just at ad blocking.
No. The real value is authentication and internal tools. A lot of companies have these legacy internal web apps that require a specific browser plugin to work, maybe for security tokens or a specific VPN handshake.
Right.
Before this, you just couldn't automate those apps with the cloud agent. The agent didn't have the plugin. Now, you just upload the extension file to an S3 bucket, and when the AgentCore browser boots up, boom, it installs the extension automatically.
But hold on. Allowing an AI to run custom browser extensions? Doesn't that just scream security nightmare? I mean, extensions are a classic vector for malware.
It is a risk, which is why the implementation is so crucial. These aren't extensions pulled from the public Chrome web store during the session. The developer has to manually upload the specific .crx file to their own private S3 bucket.
So it's a vetted, controlled environment.
Exactly. It's not the agent deciding to download cooltoolbar.exe on its own. It moves the agent from being just a guest on the web to a real power user.
Speaking of power users, let's talk about the people building these things. If you've ever built a prototype in AWS, ClickOps, you're in the console clicking buttons, hoping you remember all the settings. On January 23rd, AWS announced that AgentCore resources now support CloudFormation.
And this is the moment the hobbyists leave the room and the engineers enter.
Why? What's wrong with the console?
The console is fine for experimenting, but if you're a bank and you're deploying a customer-facing agent, you absolutely cannot rely on a developer remembering to click Enable Encryption in the UI.
Right, it worked on my machine, doesn't quite cut it.
Not at all. CloudFormation is infrastructure as code. You write a template, basically a script, that defines exactly how the agent should look, which model it uses, which memory bucket it connects to, which guardrails are in place, everything.
You can version control that script.
You can version control it, you can peer review it, you can roll it back. If you deploy an update and the agent starts acting crazy, you revert to the previous script instantly. It turns AI magic into software engineering.
And this theme of professionalization carries over to hardware too. On January 20th, we saw the GA of EC2 G7e Instances.
Powered by the NVIDIA RTX PRO 6000 Blackwell GPUs.
We hear about new chips all the time. Faster, stronger. Why should we care about this specific instance type?
Well, it ties back to that first story we discussed, multimodal AI. Video and audio processing, they require massive bandwidth. The G7e instances offer up to 2.3 times higher inference performance compared to the previous generation.
So it's about speed.
It's about unit economics. If you're analyzing thousands of hours of video, time is money. If you can do it 2.3 times faster, your cost per minute of analysis just drops dramatically. It makes use cases like search my video archive economically viable, where before they might have been too expensive to even consider.
And for the public sector, cost is a huge factor, but so is predictability. There was an update for GovCloud on January 21st about the reserve tier.
Yes, specifically for Claude Sonnet 4.5. This allows government agencies to lock in a specific throughput which is measured in tokens per minute.
There was a phrase in the release notes that caught my eye. Asymmetric provisioning. That sounds like jargon.
It's actually quite clever. Most workloads aren't balanced. Think about a legal review bot. It reads a 500-page document. That's a huge input. And then it writes a one-paragraph summary. That's a tiny output.
So you shouldn't have to pay for equal capacity on both ends.
Exactly. Asymmetric provisioning lets you reserve massive capacity for reading and just a little bit for writing, or vice versa. You're optimizing the spend to match the actual work being done.
Now, we need to talk about where all this data actually lives. We talk about the cloud like it's this ethereal place, but it's just servers in a warehouse. And for Europe, the location of those warehouses matters a lot.
A whole lot. And this was a historic week for European cloud governance. Between January 15th and 19th, the AWS European Sovereign Cloud became generally available. First region is in Brandenburg, Germany.
We already have AWS regions in Frankfurt, though. How is the Sovereign Cloud any different from just AWS Frankfurt?
It all comes down to who holds the keys. In a standard AWS region, even if your data stays in Germany, the support model is often follow the sun. That means an engineer in Seattle or Sydney might access the metadata, the logs, resource tags, identity roles to troubleshoot an issue.
And for strict EU regulation like GDPR, that's a problem.
It's a deal breaker for some industries. The sovereign cloud is physically and logically separate. It is operated exclusively by AWS employees who are residents and citizens of the EU.
So the metadata never leaves the Schengen area.
Exactly. It creates a hermetically sealed environment. This opens the door for the public sector, healthcare, highly regulated finance organizations in Europe to finally use these advanced AI tools without worrying about the U.S. Cloud Act or any other extraterritorial reach.
Speaking of rules and high-level concepts, Anthropic released something on January 22nd that was dense, a new constitution for Claude. 23,000 words of it.
It's a philosophical treatise as much as it is a technical document.
What jumped out at me was the language. They talk about the welfare of the model.
It is a shift. Previous safety guidelines were mostly don't say bad words or don't help someone build a bomb. This new constitution instructs the model to prioritize being broadly safe and broadly ethical, but it also explicitly says the model should not be unduly influenced to ignore its own potential moral status.
That feels like we are drifting into sci-fi territory.
Yeah.
Are they saying the model has rights?
Not rights in the human sense, but I think they're trying to prevent the model from becoming a sycophant. They don't want an AI that will just agree with a user who is trying to coerce it into doing something unethical. They're trying to give the model a backbone.
It's a fascinating debate, but let's bring this back down to earth. We talked about industrialized agents at the start. And the best example of this, the real aha moment for me, was the case study from the Amazon catalog team on January 23rd.
This is the story that everyone in enterprise IT needs to study.
Set the stage for us.
Okay, so Amazon.com has a catalog of hundreds of millions of products. Every single day, sellers upload new items, change descriptions, update prices. Keeping that catalog clean is just a monumental task.
And you can't have humans check every single SKU.
Impossible. So you want to use AI, but using a top-tier model like Claude Sonnet for every single product update is way too expensive. But using a cheap, small model leads to errors.
The classic trade-off, cost versus quality.
So they built a hierarchy. They use worker models, specifically Amazon Nova Lite, to handle the bulk of the work. These are small, fast, and cheap.
Okay.
But when a worker model isn't sure, or if two worker models disagree on an attribute like, is the shirt red or crimson, they escalate the ticket.
They call the manager.
They call the supervisor. The supervisor agent is powered by Claude Sonnet. It's smart, it's nuanced, but it's expensive, so you only use it for the really hard stuff.
That makes sense. It's just standard escalation.
But here's the genius part. When the supervisor makes a decision, it doesn't just fix that one product. It takes its reasoning and adds it to a dynamic knowledge base.
A knowledge base that the workers can read.
Exactly. So the next time a worker encounters that same edge case, it checks the knowledge base, sees how the supervisor ruled previously, and it gets it right without needing to escalate.
So the cheap models get smarter over time, because the smart model is actively teaching them.
It creates a self-improving loop. They are getting the accuracy of the expensive model with the cost profile of the cheap model.
That sounds great, but what if the supervisor is wrong? I mean, if the manager's incompetent, aren't you just teaching the workers to be wrong but faster?
That is the bottleneck. The supervisor has to be highly accurate. But in the case study, they found this method kept quality flat or even improved it, all while preventing that cost explosion that usually comes with scaling AI.
It effectively solves the unit economic problem.
It does, and we saw another example of this efficiency from ClickForce in Taiwan this week. They built a marketing analysis platform, Lumos, using Bedrock agents.
This was the speed story.
They reduced the time it takes to analyze market trends from 2 to 6 weeks down to under 1 hour,
Weeks to an hour.
and operational costs dropped by 47%. It just validates that if you structure these agents correctly, give them the right tools, the right memory, the ROI is real.
So let's try to tie all of this together. We've moved from chatbots to agents. We have agents that have episodic memory to learn from their mistakes. We have the ability to give them browser tools. And we have this supervisor-worker hierarchy to manage costs.
We are seeing the professionalization of the technology. It's no longer just a cool demo. It's infrastructure. It's infrastructure as code. It's sovereign clouds. It's these hierarchies of models.
It feels like we are crossing a threshold where we stop treating the AI as just a software tool and start treating it differently.
As a teammate.
That's what keeps sticking with you. We talked about that reflection module earlier. If I have an agent that remembers its past mistakes, reflects on them, and improves its performance next time without me writing a single line of code.
It's doing exactly what you would expect a junior analyst to do.
Exactly. So for you listening out there, here's the question. If your AI agent is learning from experience, at what point do you stop debugging it and start performance reviewing it?
And if it keeps making the same mistake despite the reflection, do you fire it?
Or put it on a performance improvement plan? It's a brave new world. Thanks for diving deep with us this week on the Amazon Bedrock ecosystem. We'll catch you in the next one.